Luckily, you're not too lazy to breathe because you'd be in problems. Right. Your autonomic nervous system takes over, right? Even if you don't want to breathe, you breathe. That's why people drown. Because even though you want to hold your breath, your body says, nope, we're not doing that. We're taking a breath. And well, that's why people drown. People don't drown because they can't hold their breath. People drown because their body takes over and forces them to take a breath. I went to a school in the Army. It was scuba school, and they have you do these incredible things underwater and having to hold your breath. And when you first go to the school, you're like, I can't hold my breath, right? And so you can hold your breath for ridiculously short amount of time. But it turns out you can hold your breath for a very long time.
Okay, bet.
But the issue is, and they do have people drown in this school all the time, not die drown, but drown. The issue, it's called a shallow water blackout. And so what happens is that you all of a sudden you start getting tunnel vision, and all of a sudden you go to sleep, and then you wake up with someone over your chest doing CPR on you, type thing. It didn't happen to me, but it happened to someone in our class too. But one of the final tests was that you had to swim, Olympic-sized pool. You had to do 2 laps underwater, and you couldn't push off, right? You only swim to the other side. You had to touch, but you couldn't push off with your feet. And then you had to do this thing called bobbing. And bobbing is where, scuba diving tanks. In the military, you have 2 of them. They're called 80 cubic inches of, 80 cubic inches of air. And you have 2 of those tanks on your back. And so they call them twin 80s. So you had to have twin 80s on your back, empty, right? So you weren't breathing oxygen. And then you had a 15 or 20 pound weight belt. And then what you did was you had to start in the shallow end and you had to walk to the deep end. By the way, you had enough weight on you, you're sinking, right? So you had to walk to the deep end, right? And then once you got to the deep end, you had to take off your fins and your mask. And then what you had to do is you had to be there for 2 minutes. So the issue is that, well, you can't do that. Nobody can do that. So what you have to do is, the pool's shallow and it goes to the deep end right here. So you had to start right here, and you got right here, and your head's, you're still above water. And then as soon as you get right here, you're below the water. So you can last for, a while, but eventually you have to go up for air because you're walking down at the deep end. And so it's called bobbing. So you go like this, and go up to the top, and then your head would break you got lots of weight on those. So as soon as your head broke the air, broke the surface, you had to breathe, and then you'd sink right back down. And then you'd walk a little bit, you do another bob. And then once you got to right here, right, you do a couple bobs, and then you had to take off your fins and your mask. You had to put your fins around your shoulder. We do it in a mask. We put it in our teeth. Yeah, that was it. And you put it in your teeth because you had to hold on to it. And then you sat there and then the instructor who had scuba tanks on, he would sit there and he'd be watching you because you're not supposed to be panicking, right?
What a jerk.
It's crazy. But anyway, he would look at his watch and he would go, okay, your time is starting. So you stayed there for 2 minutes. And then when you were done with your 2 minutes, he would say, okay, go back to the shallow end of your point. And then you'd have to walk back to the top. I did crazy things when I was younger. I don't know how I ever made it through that school, but I did. And I almost drowned, but I didn't drown. I thought I was going to drown. You give up. You're like, you typical thing when you're swimming, you're like, oh, I need air. You don't really need air that much. When you finally need air, you'll be surprised. I held my breath for 3 minutes in that school at the very, but it wasn't, I wasn't moving. It was like, hey, how long can you literally hold your breath? And I beat everybody. I did it for 3 minutes.
I know, I would love just being able to just sit at the bottom of the pool.
That's what I did. Well, I floated my face down in the water. And just some of the happy thoughts. And
I literally just want to sit at the bottom.
As long as I got to, it was American.
wasn't there a movie with that?
Percy Jackson. Yeah, Percy Jackson.
Yeah.
About what?
Because he's the son of Triton, or not Triton, Poseidon. I always get my Greeks and Romans mixed up.
Interesting to see people. Different names.
Okay. Well, in the book they're young. In the movie they're old. In the movie they're all like seniors in high school. Yeah. All right.
Because I'm black?
What?
You call me ape.
No, I said apes.
I'm kidding.
Me and you.
No, I'm kidding.
What were you
Don't forget,
saying?
he's also working for
Hours.
Kong.
Mike was gonna steal Candace's water bottle, so I grabbed it and gave it to him. She's like, thank you. I was like, you together strong. And then he blew it out of the
I've never even heard that before.
You knew full well what I was
He got it. Now he's pulling your chain, and now you're worried now. All right. Okay. Questions on the homework?
Yeah. 7.
Number 7. All right. Let's take a look at number 7. All right. Quiet, please. So it says number 7. We are supposed to make a perpendicular on a triangle from HJ. And by the way, if you notice on HJ, it doesn't have segment over the top. It has line. That's kind of the key. So you got our unfavorite triangle, which is the scaling of obtuse triangle. So you got H, J, and G. And it says make a perpendicular. And it doesn't say segment. It says line HJ. And that's kind of the hint. So all they wanted you to do was put a dotted line right here. And then we're doing a perpendicular from G down here. So this is what construction? This is construction 6, where you have a line and you have a point and you need to make a perpendicular from that point. So you open up your compass to any distance, at least as long as it can fit to this line. You make an arc here, you make an arc here. Then you open it up to a different distance and we go from these 2 arcs right here. You make an arc above, you make an arc below. You go from here, same distance, arc below, arc above. And that's how you make it. Okay. And the teacher book says use construction 6, and that's what I just did. Okay. Hey, once again, how am I going to grade this test, right? Well, that's a perfectly reasonable question to put on a test right there. I can only grade it by looking at your arcs, right? What?
Just the lines aren't straight.
Well,
He
granted,
just
I didn't
did
use it with a compass, right? But that's what it would look like. All right, anybody else? That was number 7. All right, technically it says do the indicated construction clear enough so that your method can be understood easily. So the book actually says which construction to use. I'm just looking for your markings. All right, so you have what, 1 through 10 all. I do want to talk about 9 and 10. Okay, I'm just going to tell you straight up, I'm going to put one of these on the test. Okay, so in number 9, it says it wants you to make an angle that's 45 degrees. Okay, well, no, you're not going to pull out your protractor and mark 45 degrees. How are you going to make a 45-degree angle?
You pray.
Right? How do we make a 45-degree angle?
Protractor.
Yeah, but what's the construction?
Protractor.
We don't have a compass technique to make 45 degrees.
Just take your hands.
Okay, we got to make it with just the compass and not the protractor, the straight edge. How do you make 45 degrees? This was question number 9, by the way.
I didn't get that from there.
Well, let's think about it. Think about the number 45. What comes to your mind?
4 and a 5 put together.
How about 90 degrees?
That did not.
And then you have that.
And then you have that. So here we go. Could you make a right angle with your compass and a straight edge? And the answer is yes. You can make the perpendicular bisector. You can make what I just made, which is a point, make a bisector or make a perpendicular. We make a perpendicular, and then what do we need to do with that? Matt. This is where you're losing it. And what do we have to do? We got to make an angle bisector, which was construction, I don't know, 3 or 4, right? We make an angle bisector of that 90 degree. Remember, angle bisector is you open up your protractor, you make an arc. Yes, thank you. Compass, you make an arc, then you go from this point and this point right here, the same or a different measurement, you make an arc, and where they intersect, there's your 45 degrees. Yes, does that make sense?
Yeah.
Okay. That was number 9. Number 10 says make an angle that's 135. How in the heck are we going to do that? 135.
Take 180. Do something.
Does that number look familiar? 135?
Oh, you decided 45 to 90.
we need to make a 90 and then add a 4. Okay, this one takes time. Okay, I can think of 2 ways of doing it. Hey, guess what that angle is right there?
90.
What?
90.
No,
130.
it's 135.
Sorry, I thought the line past was. a
Yeah,
mistake.
from here to here would be, well, we just bisected that. So technically, when you did number 9, which was says to make a 45-degree angle, guess what? You got a twofer. You also made a 135 if you realized it. So number 10, there was no work involved. You could have pointed back to question number 9 and said, hey, there you go, there's 135. I will absolutely 100% put something like this on the test. Expect there to be, and it won't be 90. I mean, both of these are fair game, and I will remind that to you the day after the test. You're like, I don't remember doing that. Okay. All right. So I will collect homework at the end of class. We are going to take a break from constructions. It's not really a break. We won't actually do any constructions today. We got a couple, 4 theorems. I'm going to warn you. Today is ridiculously easy and hard at the same time. These are words that will not stick to your brain one chance. There's not a chance that you will remember these words. In the end, we get one formula. It's going to be 4 things. We get one formula out of one of these 4 new words. If this doesn't go in your book of truth, you don't have a chance. It's got to go in your book of truth because you're not going to remember these words.
I didn't get one though.
I gave Chris 2.
Cheers. You left me to die.
All right.
Who was it?
Today we're going to get a formula. We'll go back to constructions tomorrow. We'll take a day off, or not a day off, but we'll take a day of review and we'll do the constructions to make sure that all 8, we're up to, is it 8? Yeah, all 8 constructions are fresh in our minds so that we can take the quiz and do well on it on Friday. Here's your homework. I'm going to warn you, today is not an easy day in terms of new material. It's actually an easy day because there's really only one formula that we get from this. The formula is, well, you got to wrap your head around it. It's not too hard, but I will see some students struggle with this formula. Hey, Matt and Danny.
I'm trying to fix his compass.
I know, but we don't need to do that now. All right, way back. I forget, and I should remember this. I do it every year. We had a section where we made triangles, and we talked about medians, and we talked about altitudes. Okay, and I said that eventually the homework that we did there will come to a chapter where we actually use it. Today's that day. So today's class is about a triangle and about 3 things: bisectors of angles, medians, and altitudes. Those 3 things. I said there's going to be 4 words, right, that we get from this, and they're not very memorable. Here we go. Danny, do I have your attention? I'm saying I don't think I do because I think you're way distracted with what's in your hands.
Does he need a compass?
I said from the start of the class, we're not doing anything with the compass protractor today. All right. So the class is called Concurrent Lines. Here we go. Really confusing vocabulary today. The nice thing is it's all going to go in your book of truth so that when you get questions on this, you're like, I don't remember what that word means. You simply look in your book of truth. All right, 4 basic concepts, 1 formula. The 4 concepts each come with 1 word, right? And like I said, as long as you write it down, we'll be fine. Okay. No one, including me, keeps these straight in their heads, right? I have to all the time, wait, it's that one. Which one is that one, right? They just don't really stick with you. Here we go. In your book of truth, it does say box 1, but I put this one in your book of truth. We're going to be talking today about concurrent lines. Really easy idea. And if this was the only thing here, there would be no confusing. Concurrent lines are when 2 or more lines intersect at one point. So you start with 2 or 3 or 4 or 26 lines. And if all of the lines intersect at one point, not 2, But if they intersect at one point, we say the lines are concurrent. Okay? Hey, there's a picture. Those lines are concurrent. Why? Because they intersect at one point. L and M intersect at one point. Danny, I know you're distracted. You have to stop being distracted and start writing things down. Concurrent lines. Two or more, and there will be more, three today. Two or more lines today. They have to intersect not at multiple points, but at one point. Matt, are these concurrent lines?
Yeah.
Why?
Because they intersect at one point.
Are these concurrent lines?
Yeah.
Why?
They intersect at one point.
Are those concurrent lines? Why not?
Because they don't intersect.
Well, they intersect
At 2 points.
at 2 points. That's the idea, right? Concurrent lines must intersect at 1 point. Okay, if that was the entire class, no one would be confused. Okay, that's the easy word. The other 3, not memorable. Concurrent lines, we okay? Easy concept. Now we come to the challenging words. All right. A long time ago, I forget what chapter, but it was early on. It was when we had triangles. They had you do this for homework. They gave you a triangle and they said construct the 3 angle bisectors, then construct the 3 altitudes, and then construct the 3 medians and see if the lines intersect. And it turned out that they did. I'm not sure why they did that way back when, and they waited to this chapter to talk about it, but they did. All right, we're going to do a proof first. So this is not a proof that I want you to write down. It's a proof I want you to watch me do. All right, you ready? Okay, I'm taking a triangle. It could be any triangle. It could be right. It could be isosceles. It could be equilateral. There's nothing specific about the triangle. What I'm going to make is I'm going to make angle bisectors of the 3 vertices. Everybody with me? I'm making angle bisectors. So what we're trying to prove is that not only will these 3 angle bisectors be concurrent, that means they're going to intersect at a point, that point, if they are concurrent, and they are, is equidistant to the 3 sides. Like when we find the point of concurrency, let's say it's right here, that the distance between that point and the 3 sides is exactly the same. That's what we're going to try to prove. So it's kind of like this point is sort of in the middle, sort of. It's not a good term, middle, okay? But what it is it's equidistance to the 3 sides. That means that this is 3, this would be 3, and this would be 3. Seems kind of crazy, but it's true, and we're about to prove it.
That seems like it'd be extremely useful too.
And it is, not this one, but another one like this one will be very useful. I'll show you. 2 of them are useful. 1 of them is just kind of a neat thing. All right, so that's what I got to do. So I got to prove 2 things here. One, I got to prove that all 3 of these angle bisectors intersect, and they're at 1 point, so point of concurrency, and that they're equidistant to the 3 sides. Seems like a lot to do, and it is. All right. So here's the idea. You ready? Pick 2 of the angle bisectors. It doesn't matter which 2.
B and C.
Extend the lines. Would they intersect? They have to, right? Because they're not parallel, right? So and I could pick any 2. I'm gonna choose A and B. And nothing special about A and B. Those are just the 2 I'm gonna choose. So I'm gonna choose A and B, and I'm gonna extend them. Well, clearly they will intersect. Where they intersect, I'm gonna call point L. Okay? Not just construction. All I'm doing is extending the lines. All right, cool. Now what I'm going to do, because I need to show that this point L, by the way, I haven't shown that it connects to C. I've only shown it connects to ray A whatever and ray B whatever. I haven't shown that the angle bisector coming from C actually is concurrent, right, with point L. It turns out it is, but I haven't shown that yet. What I want to show, though, this is where it gets a little messy. I want to show that point L is equidistant to the 3 sides. So in order to do that, well, I'm going to measure it. I'm going to measure from L to side AC. I'm going to measure from L to side CB, and I'll measure L from side AB. And remember, when we measure, it doesn't show very clear. It's perpendicular distance. So I just made 3 perpendiculars. Okay? Say again? Yeah, that's just construction. And we can make, and all I did was make 3 lines that go through point L that are perpendicular to the side. Okay? All right, cool. We've done that. Believe it or not, I can immediately claim that all three of these red lines are equal to each other. Believe it or not. So the question is why? I mean, I didn't do anything other than draw it, and then I'm claiming that they're equal to each other. Here's the interesting thing. The reason why they are at is because, well, we made angle bisectors. A long time ago, we had a theorem that said that if you make an angle bisector, that any point along the angle bisector is equidistant to the two sides. We have that theorem, right? So I can immediately claim that this line right here, because it's along this bisector, is congruent to that line right there. Well, wait a minute, this is an angle bisector, so I can claim that this one is congruent to this one. And that's what I'm doing right here. I'm saying that IT is equal to IR. They're on this angle bisector. Oh, they are the same size because they live on the angle bisector.
If you look at it, you can see it's impossible for them to be the same.
They all look the same.
They're all the same. Okay. And if you don't believe me, you can open up your book. This is the picture from the book. All right. Cool. Now look what this says. It says IT is equal to IR. IR is equal to IS. Therefore, by the transitive property, if IT equals IR and IR equals IS, then therefore we could also say, and that's just transitive. And now I've just proven half of what I need to prove. Well, remember, I need to prove that the point of concurrency is equidistant to the three sides. I just did it. Now I got to prove that, wait, that this line right here, the angle bisector coming from C, is also equidistant. And here's how that's done. I'm going to do it basically the same way I did this one. I just showed that point I is equidistant to the two sides AC and CB. Well, if it's equidistant to the side, it can only live in one spot. It has to live on this angle bisector. Therefore, that's where it lives. It lives on the angle bisector C. Because any point that's equidistant to the two sides right here lives on this angle bisector. Boom. That was pretty actually easy to do. All right, that's the proof, and I said it wasn't worth writing down. But what is worth writing down is the theorem that comes from this. Now, this is a complicated theorem. I'm going to explain it to you as easily as I can. This is theorem 10.1. Now, before you write it down, look at me, or look at the board, sorry. Okay, here's what it's saying. Do you see black lines and red lines? Here's what it's saying. If the black lines are your angle bisectors, if you make angle bisectors, they all intersect at a point. And that point, now we're looking at the red lines, that point is equidistant to the three sides. That's what it says. If you make angle bisectors of any triangle, those angle bisectors will intersect at a point of concurrency. And that point of concurrency, red lines, are equidistant to the three sides. So in yellow is what you get. It is not memorable. You won't remember this unless it's written down. The problem will be something like, hey, look, you got angle bisectors. And then you got to think, okay, which one of those three things dealt with angle bisectors? And you got to look it up. Oh, that was 10.1. And what's the so what about 10.1 is that that point will be the same distance away from the three sides. So if you want to be in the middle of the triangle, if we define middle as the same distance away from the three sides, you go to where the three angle bisectors intersect. And to further confuse you, we're going to give a name to that point, and it won't be Fred or Bob. 10.1, if you make angle bisectors, they intersect all in one point, a point of concurrency. And that point of concurrency is equidistant to the three sides. This one's hard. We get no formulas from this. Like we don't get that, well, then therefore the sides are half of the other one or something like that. We get no formulas, but we do get the fact that the point is equidistant to the three sides. Therefore, if I give you one measurement, if IT is 4, then they're all 4. That's kind of what the homework tonight would be like. The issue is that you got it. There's going to be 3 of these. Well, it looks like this is going to be a 2-day class.
mean, that's unfortunate. I'm okay with that.
This is a fire drill. Everyone, please exit calmly and safely. This is a fire drill.
See, this never happens.
It is the end of the month. Hey, look on my thing, tell me what the temperature is outside. Upper left, upper left. What's the temperature?
On the,
The black thing.
What is happening during, what is
Oh.
your?
56.
56? I don't know. That's good.
You are to leave the building by the nearest exit or exit stairway.
You guys know the drill.
Do not use the elevator. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators. There is a fire emergency in the building. You are to leave the building by the nearest exit or exit stairway. Do not use the elevators.
Comedy.
I'm so funny.
Buddy.
love long range.
Yeah, I remember. I was outside. Okay, let me keep it. You, hey,
I still can't get rid of the picture of me in the face. I'm like that.
He does that. You know, I want to see a picture of him. No.
I can't look at them the same. All I when I look at it, all I think is the only thing is.
I left the video running too. Is there anyone
You
online?
didn't take them out when the fire drill with us, they could have burned.
I
What did you do for the last 10 minutes?
just sat here.
Sorry. Did you understand what was going on?
Not really.
Yeah, we just had a fire drill.
17?
Oh, okay.
I should actually have like a lockdown. For like interesting.
All right, let's see how much we can get through this. We're certainly not going to get through the whole lesson. So,
will we have homework?
but don't use this as an excuse for, hey, then I don't have to pay attention. This is still, you got to pay attention. We got to write everything down.
I'll try.
All right, we left off with Theorem 10.1, which said that if you have angle bisectors, no
It's
covers.
not what it looks like. It's not what it looks like.
I know, but it's no
Oh my
covers.
gosh. Now it's open, so.
No, it's not
goodness
open.
will.
It's fine. It's not open.
Yes, it is.
It opened. No, he just
It
took the
opened.
air out of it. He didn't open it all the way.
Okay, good luck with that.
It won't spell.
All right, so focus, we have angle bisectors. The three angle bisectors come together at a point of concurrency, and that point of concurrency is equidistant to the three sides. Right, that concurrency has a name, not a memorable name. You're gonna need to write it down. So you can put it next to the theorem as well too, but it has to go in your book of truth because we're gonna use this word and you'll say to yourself, well, I don't know what that means if it's not in your book of truth. So that concurrency that's formed by angle bisectors, right, is called an incenter. You're like, isn't the thing we had before? No, that was inscribed. Like I said, these words are not very memorable. This is called an incenter. An incenter is formed by angle bisectors. It's that point of concurrency. And the incenter is, by Theorem 10.1, the incenter is equidistant to the three sides. We're going to get three of these words. That's one of three. The fourth word is the point of concurrency, and that was easy, or concurrent lines.
Is that like a surprise drill?
Yeah, we have to stop not telling the teachers when they. So you start off the year by everyone knows when they are, and then it gets to, well, you don't tell the teachers when the drill is. I don't know. It seems silly, but that's the way it goes.
Why do we only do fire drills?
We have to do all of them right eventually. So it is our option of which ones we do.
We're gonna try to shoot up Liberty Tree.
Apparently no one. Of course.
All right, back up here, please. Back up here. All right, incenter. We got this written down, yes? Like I said, we're going to get, listen, please. We're going to get three of these words. If you don't have them written down, they're going to throw all three of them at you, and you're going to be, I don't know what that means. It has to be in your book of truth. You will not remember incenter. Okay, incenter. Black is how it's constructed. Red is the consequence. The black means it comes from angle bisectors. The red is the result. The result is that the point L is equidistant to the three sides. What are they going to give you for homework? They're going to say that one of them is 3, and they're going to ask about the, well, they're all 3, right? And if it was just that, it would be nice and easy, okay? But there's 2 more of these. We won't get to the third one. We'll get to the second one. All right, 1 down, 3 to go. All right, here we go. This time it's not angle bisectors, it's, read it. This time we're not making angle bisectors, we're making perpendicular bisectors. You see how I'm saying this is going to ramble around your head? Right? This is why it has to be written in your book of truth. Now, you're going to watch me do this proof again. This proof is done exactly the same as the previous one. But it's not angle bisectors, it's perpendicular bisectors. So these 3 little arrows coming off are perpendicular bisectors of the 3 sides of a triangle. So it turns out they intersect. And we're going to show that not only do they intersect, is that they are, oh, here it comes. You ready? It's not that the point of concurrency is equidistant to the side, it's equidistant to the vertices. Boy, that sounds exactly like the previous one, but it's not. It's not equidistance to the three sides. It's equidistance to A, C, and B. So this one really is, to my mind, like the middle of the triangle, because it's equidistance to the three vertices. Okay, the proof is done almost identical. Okay, I grouped two of these together because two of them clearly they intersect. I could pick any two. I picked those two. Okay, clearly they intersect. Danny, they intersect. The point that they intersect we'll call this time O. We could have called it L as well too. All right. Okay, great. They intersect. So what? Well, if they intersect and they are on the perpendicular bisector, then that means by definition from the previous one, if you are on an angle bisector, I'm sorry, if you're on a perpendicular bisector, if I'm on the perpendicular bisector, I know that I'm equidistant to the two endpoints. We had that as a theorem a long time ago. So I can immediately, once I make these three red lines, right? I can immediately say that the three red lines are congruent to each other. Why? Because that point right there, point O, is on a perpendicular bisector. That means that's that isosceles triangle we made way back when. That means that it's equidistant to the endpoints. And the endpoints here are the vertices of the triangle. So this one's really easy to do, and we get that same transitive thing as well. So that first part that they're all equal to each other, so they're all equal distance from the vertices is easy to do. It's just like the previous one. Further, once again, we never proved that this perpendicular bisector goes through O. It's easy to do as well too. If it's on the perpendicular bisector, check it out. If it's on that perpendicular bisector, then it's equidistant to the two sides. So I've already said that this red line and this red line are equal to each other. If they're equal to each other, then that point O must also be on that perpendicular bisector. That's how we get that. Hey, you're not paying any attention. Okay. That's how I can say those three things or two things very quickly. So that's the proof. It's done exactly like the previous one. And here's theorem 10.2. It looks exactly the same. It's different. It's not angle bisector. Remember, black is the construction, red is the result. So if you are on not angle bisectors, but perpendicular bisectors, then that point of concurrency has a name to it. That'll be the next slide. And the red is the so what? The red says that you are equidistant, not to the three sides, but to the three vertices. If you are the point of concurrency of the three perpendicular bisectors, that's the black part, then you are equidistant to the three vertices. In other words, the three red dotted lines are all equal to each other. But boy, does this look exactly like the previous one. It's not. The previous one was angle bisectors, and you were equidistant to the three sides. Now you're perpendicular bisectors, and you're equidistant to the three corners or the three vertices. Really easy to confuse. The result is the same. You get three things that are the same, but they're different in each case. One deals with side measurement or distance from the sides, and one deals with distance to the vertices. Suspiciously, I called this point of concurrency letter O. The point of concurrency, its name will start with the letter O. Previous one, the point of concurrency was an I in center. Now it's an O.
Out center.
Wouldn't that be nice? It's not.
No. Opposite side.
All right, we good?
My brain isn't.
No, it's hurting.
Connor is playing a crushing count today. I'm laughing with you. What happened to the glasses? Clearly. He's doing the monocle thing.
You know what, Connor? One day you should come in with instead of glasses, you should get two monocles and then place them on your eyes. You'll be extra fancy.
All right, here we go. Anybody read ahead? What's the point of concurrency going to be called? Starts with the letter O.
Octagon.
All right.
Orifice.
Closer. It's called, no, it's called a circumcenter.
I was nowhere near. What do you mean?
You said it started with an O.
It doesn't. One of them does. I don't know why your book,
Liar.
I don't know why your book chose O. They should have chose C. It would make perfectly good sense to me. But for some reason in the proof, they chose an O.
That's so
It doesn't
freaking
make any
dumb.
sense. It should be the letter C, but they use C in the triangle. All right. Now remember, we had the word circumscribed, right? That's the thing on the outside that touches all the vertices of the polygon. Not the same word, circumcenter. The words just don't really stick with you. Black is the construction, red is the result. Black is the construction. If you make perpendicular bisectors, the red, then you are equidistant to the three vertices. Red is the result. Black is the construction, red is the result.
Is there gonna be a proof on this test?
Don't know, I don't remember. Probably not, because it's all constructions.
Yes. No homework. tonight.
By the way, could you construct this? Sure, it's perpendicular bisectors. Okay, and we can construct that.
What happened to construction?
We're coming back to it. By the way, the reason why this fits in here, right? They're doing this right now is because in order to do this, you would have to construct a perpendicular bisector, and we just learned how to do that.
Never had to be.
Perpendicular bisector. It depends whether you're doing it from a given segment or a segment and a point. So remember, if it's a segment, we're going to practice this, by the way. If it's a segment, you open up to more than halfway, right? Arc, arc. Then from these 2 points, arc, arc, and that's your perpendicular bisector. But you are going to look at what you have written in your book of truth and follow the instructions. You don't have to have it memorized. All right. It's getting slightly confused because we got 2 terms now and we're out of time, and we're going to do this continue. I'm going to have to quickly go over this again tomorrow. Okay. There are 2 left. There are 2 of these left. All right, we'll stop right there. One of these we are going to get a formula from out of the 4. Number 4. No. All right, Bree, we're going to, because of the fire alarm, we're going to stop it right there, and we'll pick up where we left off tomorrow. I'll do a quick review as well tomorrow. Who else is online right here? Jenna as well
Okay.
too. Jenna, did you understand we were having a fire drill there?
Yeah, I understood.
All right, cool. Yes,
right.
I do. Catch you guys tomorrow.
Bye.
Bye.